Hey everyone, welcome back. So today we're going to be solving another problem. It's Leetcode 1760, minimum limits of a balls in the bag. Okay, this is actually a problem of the day for today, and I've not solved this problem before. As you can see, I don't have any submissions on this problem as such, but of course I do know the approach for it, and I have gone through this problem as in the question, and I know what the question is asking, and I know an approach for it, but yeah, I've never tried it. So we're going to be trying it today, and I'm going to be trying it with you. So yeah, let's solve this problem. Okay. So the problem statement is that you're given two variables. One is nums, which is nothing but a array, and max operation is a variable. Okay. So nums basically contains bags, and inside each bag you have certain balls. Okay. Nums of I represents the ball in the ith bag. Okay, so basically if you have 2, 4, 8, 2, you have 4 balls in the second bag, 8 balls in the third bag, and 2 balls in the last bag. Okay, so our task is that so basically you have another variable called max operations, right? So basically what that means is you can perform max operations. That is, for example, if the max operation is given here is 4, you can perform 4 operations in nums. What are the 4 options will come to, but you can perform 4 operations, at most 4 operations. You can perform any operations greater than that. If it's given to you as 4, at most 4, you cannot perform 5 or 6 operations. Right. Now let's come to what operations can you perform. Okay. So given an array, right, you can perform perform operations in a way where you can break an element into 2 parts. Okay. It can be anything. Right. It can be 3 1 or 2 2 or 1 3, whatever it is. You have to break the element into 2 parts, not 2 halves, 2 parts. Okay, in such a way that after performing n number of operations, for example in this case, after performing 4 operations, your resultant array should be in such a way that the maximum element is minimized. By that what I mean is, if I break everything, let's forget the operations for a while, let's not think about that. Let's say I break everything into halves, 2 parts. Okay, let me break 4 into 2, and then 8 also into 4, and then 4 into 2 again, so 2 2, and then 2 also into 2. This will actually, wait, my bad. So if I break 8, that'll be, if I can break 8, I can break it into 4 and 4, and each 4 will be 2 and 2, and this also will be 2 and 2. So let me do that. 2 2, for that 2 2, and then my finally 2. Right. This is my resultant array. Okay, this is according to the number of operations only, but I've not shown you how we do it. But let's assume that we have broken it down into the resultant array. Okay, now in this resultant array, the penalty, that is the final resultant array, the penalty of the final resultant array is such a way that you will be taking the maximum element in the resultant array. That is your penalty for doing these operations. That is the price you have to pay for doing these operations. Now it is your job to minimize that penalty. Right. By that what I mean is, in the resultant array, your job is to be minimizing the penalty. Penalty would be taking the maximum element. You need to make sure that that maximum element is minimum. Okay, I know it's a bit confusing, but stick around. Okay, see, in this, let's say that I'm not performed any operations. Let me consider this array itself. Okay, and let's say that I'm not performed any operations. Let it be like that only. Let's say this is the resultant array. What is the maximum element over here? It is 8. Now this would return as 8. 8 is the maximum element. Okay, now if I can break this 8 in such a way that I would get a resultant array lesser than 8. Right, I can break it into 4 and 4. This 4 and 4 I can break it into 2 and 2, and that is exactly what we have done over here. Okay, so I've broken this 8 into 2 and 2, 2 and 2 by these operations, by these number of operations. Now when this is the resultant array that you get from this, now can I say that the maximum element that you get is 2, which is less than 8? Right, now it makes sense. Right. Your penalty is the maximum element, but in this case your penalty was 8, but in this case your penalty is 2, because we have reduced the maximum element in such a way that the maximum element of the resultant array is minimized. Okay, so this is the problem's ask. And it's a bit confusing, but if you look into this, and you break it down, you will understand. Okay. Now, yeah. So basically, that is the problem's ask, and we'll have to figure out a solution. Okay. And the constraint given to us is 10 power 5. So any solution with n square complexity would give us a TLE, because it would be 10 power 10, and that would cause us a TLE. I've discussed this in the previous videos. You can watch that. Why would we get a TLE? But yeah, n square would get a TLE. We need to find an approach which is optimized. It can be anything, n log n log n. It can be anything, and we're going to look into that. Okay. Now let's take this example. Same example, 2 4 8 2. Okay, 8 2, and let me index it 0 1 2 3. Okay, let me index it. Let's come to that. Okay, here I have this element. Now let's look at something. Let's make an observation. Okay, can I say that the maximum? So okay, since it's a bit confusing, let's actually reduce the complexity. So see, here the question is asking us to minimize the maximum value, right? Minimize max value. That is what the question is asking us to do. Minimize the maximum value. Okay. Now forget minimize maximum value. It's a complicated term. Let's not think about it. It's not required. Let's just say that we need to figure out something in the array such that the resultant array has a value which is less than 8, which is less than the maximum value. Let's just think about that. By that, what I mean is, you have the maximum value of the array is 8 for now. Right. As you can see, 8 is the maximum value. Now, can I say that any value greater than 8 is not going to be there? Is not going to be my minimum value, right? Because even if I split 8 into whatever combinations it is always going to be less than 8, right? We know that for sure. My maximum value is 8, and no value will be greater than that, right? So I know that. So now I know that whatever the answer is, it will lie less than 8, right? Makes sense, because if I split 8, it will be lesser than that, right? Whatever it is, 4 and 4 or 3 and 5 or even 1 and 7, it's going to be lesser than that. Okay, so my maximum value is 8. So on a number line, let's draw this. So my maximum value that I can achieve is 8. What is the minimum value? Can I say my minimum value can be 2? I'm assuming the minimum value from the array. Minimum of array is 2. Now can I say that my minimum value can be 2? Is it true or false? It's false, because 2 also I can break it into 1 and 1, right? I can put 1 and then 1 again. So if I have 2, I can break 2 into 1 and 1. Okay, 1 can be my minimum value. Can it be lesser than 1? No, because if you break 1 and 1, what would you get? Half and half. It doesn't make sense. It is a positive integer. So it's a positive number of balls. It's a positive integer. So my minimum value is assumed to be 1. So now I know, hey, whatever my answer is, it is going to lie. Whatever my answer is, it's going to lie between this range. I know that. We just need to find out what is that value. Okay, let's see. Now let's go by the brute force approach from 1 to 8. Okay, let's take 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Now and then you have the array of 2, 4, 8 and 2. Okay. Now so what are these? These are nothing but the number of balls. These are minimum penalty, ball penalty. Okay. So ith bag contains number of balls. These are nothing but the number of balls. Okay. Now let's go through each and every this thing. Okay. Now can I say that I need to arrange my array in such a way that let me pull this closer actually. Yeah. I need to arrange the array in such a way that the maximum value that I get is 1. Is it possible? Is it possible? The maximum value that I have is 1. So if we have 2, I'll break 2 into 1 and 1. If I have 4, I'll break 4 into 2 and 2. Again 2 into 1 and 1, 2 into 1 and 1. Same thing with 8. 8 into 4 and 4, 4 into 2 and 2, 2 into 2 into 2 into 1 and 1, 1 and 1, 1 and 1. Right. Remember that each breaking costs you an operation. Okay, each breaking will cost you an operation. So if I have I have 8 balls in total. I have 8 different. I have 8 combinations. Not 8 combinations. My answer lies between 1 to 8. Now, can I place my 1 in such a way that the maximum value is 1? I can, right? I can. But the constraint given to us is that you can do it only in 4 operations. Operations is 4. Okay, can I do it? Breaking this itself will give you 1 operation. Breaking this into 2 and 2 will give you 1 operation, and then breaking it down to 1 and 1 will give you 1 more operation. That itself will cost you 3 operations. And then coming here, it will be 2 and then 1. Again breaking it to 2 and 2 and 2, 1 and 1, 4 operations. It'll be greater than 4. Obviously, that's very simple. So I cannot take 1. Let us ignore 1. What about 2? Can I take 2? Can I make sure that the maximum number of elements that in the array is 2? Okay, 2 is 2 only. 4, I can break it into 2 and 2. Number of operation that cost us is 1. Okay, now it is 2. Now 8, I break it into 4 and 4. Operation became 2. Now 4, I'll break it as 2 and 2. Operation became 3. This 4, I'll break it as 2 and 2. Operation became 4. Now we have 2. It is good. Now is it possible? So we have made sure that now our resultant array would look something like this: 2, 2, 2, 2, 2, 2, 2, and this final 2. A result array will look something like this, and we have completed it at 4 operations. Okay. We made sure that we have split the array in such a way that we get 2, maximum number of 2 within 4 operations. Yes, it's possible. Right, makes sense. So let me mark this as possible. Though this is the answer mentioned over here, we will iterate through the entire thing. Okay, now this is possible. Let me go to the third. Okay, let me. Okay, let me go to the third. What about 3? Ideally, I should have started from the last. Okay, because now that we received 2, this will be our minimum. Okay, this let's do one thing. Let's go from 8. Let's consider 8. Okay, now okay, let's consider 8. If I take 8, this would not require any operation. Operation would be 0 on this. Operation would be 0 on this. This is also same. Operation would be 0. Operation would be 0. Okay. Now it has costed us 0 operations, which is less than 4. So I can consider my 8 also. Right. 7. Can I consider 7? Number of operations that I need is 0. 0. 8. I need to break it in such a way that I get 7. So if I have in a bag, if I have 8, how will I split it? Can I split it in such a way that it's 1 and 7? I can, right? I can. Now it's very simple. See, you have a bag. Okay, you have a bag. Let's assume you have a bag, and let me draw it like this. You have a bag which contains 8 balls. Now you're splitting this 8 balls. You take 2 bags. One bag you will take 2 bags in such a way that the maximum value is 7. Maximum value is less than or equal to 7. Right? You can split 4 and 4, you can split whatever it is, but the maximum value should be less than or equal to 7. Let me take one ball over here and then let me break it into 7 balls. So how many times are you breaking? You're breaking only once. Right? You're breaking only once over here. You're not breaking more than once. So the number of operations performed is right. Makes sense. Now let's come to okay, again for 2 you can, because it will cost you 0 operation. So number of operations is 1. This is for 8. This is for 7. Let's ignore 6. Let's come to 5. Okay, let's come to 5. So for 5, for 2 you don't need any operation. For 4 also you don't need any operation. For 8, how do you split it? 8 you need to split in such a way that you have 8 balls. You need to split it in such a way that the maximum value is less than or equal to 5. Okay, so can I split it like this? Can I split it as 4 and 4? So what will I do? I have 8, I'll take 2 bags, I'll put 4 over here, and I'll say that, hey, it's split. Let's split in such a way that the value is less than or equal to 5. So how many splits do you need? How many splits do you need? You need only one split. For this also you need 0. This is for 5. When the maximum value in the array is 5. 6 is done, 5 is done, 5 is done. Let's come to 3. How would you do it for 3? For 3, you can store 2 balls easily. This is for 3, I'm doing it. Okay, you can store 2 balls easily. So what I'm going to do is 0, this will be 0. For 4, how can you store 4 balls in such a way that the maximum limit is 3? Again, break it. You have 4 balls. How will you break it? Can I break it as 1 and 3? Or can I break it as 2 and 2? Yes, I can, right? The maximum value has to be less than or equal to 3. I can break it in these ways. So what is the maximum number of operations that I need? I need 1. Okay. Now, for 8, how do I break 8? Next, I'll come to 8. So maximum number of operations that I need is 1. Okay. For 8, how do I break it? I have 8, and then I'll break it as such that maximum value has to be 3, isn't it? Okay. Can I break it as 5 and 3? If I break it as 5 and 3, the maximum value would still be 5. I can't do that. Okay, I can do that, but I have to split it again. Let's check. Let's hold 5 and 3. Let's come to another one. What about 4 and 4? If I have 4 and 4, okay. If it's 4 and 4, that's still greater than 3. Then I have to split it again. Okay. What about 6 and 2? Yes, 6 and 2 can be done, but I have to split it again. Right. Now, 6 and 2, 4 and 4, 1 and 7 also. 7, I have to split it again because the maximum value is less than 3. Let's assume one of them 5 and 3. Now, so you have 8, you have bag with 8 balls. You split it into bag, you put 5 in one bag, and then you put 3 in another bag. Right. Now the maximum has to be less than or equal to 3. Now you have to split 5. This is okay. You have to split 5. So the number of operations that you performed is 1 over here. You have to split 5. Let's split 5 now. How will I split 5? I have to split 5 in such a way that the value is less than or equal to 3. Can I split it as 2 and 3? Can I split it as 2 and 3? So number of operations that I got is not over here. This will be when it's branching out is why you get it. Number of operations that I got is 2. Makes sense? Makes sense, right? Number of operations that I got is 2. Okay. Now, so 8 would take 2 operations. 2 operations, I believe. Okay, 2 operations. What about 2? I don't need any operation. So the total number of operations I need for 3 is 3. Okay. Now, 3 is done. 4 also be the same. Let's do 1 only. Let's do. Okay. You know what? Let's take another example. Because this we already got the answer. Let's take an example of 9. and my array contains 9. What is the max value? Maximum value would be 9. It cannot go greater than 9. What will be my minimum value? My minimum value will be 1. P1. Okay, now let me write it down like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, let me actually do 2 for 2. This will make you understand. Okay, can I say that I have to split array in such a way that my array, the resultant array, should have a maximum value of 2, right? The number of operations that is given is 2. So you can perform max of 2 operations. You cannot perform max of 3 operations. It has to be 2. Whatever it is, it has to be 2. Okay. Now, the maximum value has to be 2 in the resultant array, how do I split it? So just think about it literally. You have bags with 9 balls. How would you split it? Can I split it like 6? Or can I split it like 8 and 1? I can. Okay. This is first split. How do I split 8 in such a way that the resultant array has max 2? Can I split 6 and 2? Yes, I can. How do I split 6? Can I split it as 4 and 2? Yes, I can. How do I split 4? Can I split it as 2 and 2? Yes, you can. So the number of operation that is costed you is 4. Now what is the operation that you need? 2. Now tell me something. I've not gotten it for 2. Okay. For 2 itself, I've not gotten the right answer. As in, I've gotten 4 operations which is supposed to be 2. Can I say that whatever is less than this, also I won't get any answer? Makes sense, right? I won't get any answer. So I need to go this way, down. So this I can eliminate. Now let's consider for 3. How do I split 9 into 3? Such that the maximum element is 3. How do I split my 9? Can I split my 9 as 6 and 3? Yes, I can. Can I split my 6 as 3 and 3? Yes, I can. Yes, we have not achieved it. I've split my resultant array in such a way that the maximum element in the array is equal to 3. Perfect. Now I've achieved it for 3. Let's mark it. Let's talk about 4. How do I split my array into 5 and 4? I can split it. Of course I can. 5, how do I split it? 4 and 1 I can split it. Yes, you can. This also you can. But what is the question asking us? Question is asking us to return the minimum. I mean, your task is to minimize the maximum value. So can I say that with 3, if I get it, that is my minimum value that I can return? I can say that, right? If I get 3, yeah, I can say that is a minimum value, because 4, 5, 6, 7 also I can do it with equal to 2 operations or less than that also, because for 9 I need 0 operations. Okay, so 3 is the minimum one. This I can get it, but with 3 is a minimum value that is maximized. So can I say that 3 is my answer? Can I say that 3 is my answer? Yes, I can. Now if you see over here, 3 is also your answer. But tell me something. If in the program, while you're coding, if I'm asking you to split 9 such that the maximum element is 3 in operations. Forget the operations. How do you split 9? How do you split 9 such that you get the maximum of 3, and how many operations would it take? If I give you a question, hey, I give you 9 balls and I give you maximum it can be 3. You have to tell me how many operations will it take. What will you do? Ideally, you'll split 9 into 6 and 3. 6, you'll split it into 3 and 3. So you'll say, hey Siddharth, it took 2 operations for me to do it. You'll say that. Right. Now, how do we find this easily? Is this the right approach? How would you do it? You have to split 9 into 6 and 3. And then you'll have to split 6 into 3 and 3. And then you'll have to check if it's less than or equal to 3. Then you have to. Is there a mathematical formula that we can use to do this? Let's think about it. Okay, let's talk about the formula, then let's do it. Okay. Now, 9 and 9, see, can I say that if I split my 9 by 3 parts, that's what division is, right? Splitting 9 into 3 parts. What is the floor value? Floor value is 3. Seal value is also 3, but because you get a whole number because it's divisible. Okay, so you have 9, okay, and you're splitting it into 3 parts. Split it into 3 parts. Okay, tell me something now. You have 9. This is your 9. You're splitting into 3 parts. Okay, now you have 3 parts over here with you. 1, 2, and 3. Perfect. Though you have split it into 3 parts, how many splits did you actually do? You did 1 split, 2 split. Did you do 3 splits? No, you did 2 splits. Right. So you need the number of operation. Number of operation is nothing but the splits that you're doing. Right. How many splits are you doing actually? We have to get 3 parts. You're doing 2 splits. Right. Makes sense. Let's take another example. You'll see you're dividing 11 into 3 parts. Dividing 11 into 3 parts. What's 11 by 3? 11 by 3 would be, I need the exact value, 3.66. 11 by 3 will give you 3.66. This will be my floor value will be 3, seal value will be 3.6 only. Seal value will be actually 4, I believe. My floor value. This will be my seal value. I think it's CI, whatever it is, seal value. Now, can I say that if I'm splitting 11 into 3 parts, okay, so I'll split it as 11 into 3 parts. I can split it as yeah, 3. How will you split 11? Okay, let's take the floor value itself. Okay, you get 4, right? So 1, 2, 1, 2, 3 you have 4. So 11 by 3, you split 11 into not 3 parts, you split 11 by 3, so you get 4 parts in total. So you get 1, 2, 3 and 4. Okay, perfect. How many splits are you doing? You're doing 1, 2, 3, only 3 splits. So now with this, can I say that any number by the number of split, any number by, let's say any number by, what is the other side? What do we call it? Number of balls, right? If I'm splitting it, any number by, let's say number of balls equals to m, okay? By m, seal value of this minus 1 will give me the number of operations. This would result in number of operations. Can I say this? I can, right? I just showed you how we do it. I can. Good. So this is exactly what we're going to use. Now, you might ask me, hey Siddharth, if you're splitting 9 into 6 and 3, then it's okay. What about if you're splitting 9 into 5 and 4? Will the number of operations change to get the maximum value as 3? Let's see. Number of operations it took is 1. 5 it took 2 and 3, number of operations became 2. 4 you're splitting it into 1 and then 3. Number of operations became 3. Yes, it is. Okay. Now, but would this just be the same thing, or am I splitting it by 3? Right. Okay. So now I understand that I can split it how many ever ways I want, but by doing 9 by 3, I'm finding the most optimized way. So by doing 9 by 3, I'm actually splitting into 9, 6 and 3. This I'm actually splitting into 3 and 3. This I'm doing it by the most optimized way. I can do this as well, but this is not optimized. I mean, this will give you more operations, end of the day. So when I'm doing 9 by 3, which is 3 minus 1, 2. So the most optimized way to split 9 in such a way that you get the maximum of 3 is 2 operations. That's exactly what I'm doing. Okay, perfect. So now that we have gotten the formula, let's go back. Okay. Now with this, of course, I can go through this linearly, either from top to bottom or bottom to top, doing linear search. Either from top to bottom, doing linear search. Can I say that when I find my answer, I'll break? No. When I find my answer, I'll update the answer, and if it's the least answer, I'll break, or else I'll keep moving. This is linear search. What is the time complexity? N. But do we really need linear search? Can we not think of something else where you have given a sorted array and you have to find the minimum value? For this, wouldn't binary search be the best candidate? Yes, it is going to be, because I can easily find the minimum value with the condition that I just gave you. If it's not possible with 2, it's not going to be possible with 1, which means that I can discard this. If it's possible with, let's say the mid value is 5, if it's possible with 5, of course it is possible because it's possible with 3. Can I say that whatever is greater than this is not going to be my minimum value? So I can discard this value. So I'm going to go to this value. This is how I'd apply my binary search. So this would give us the time complexity of log of the range that we're taking. That is nothing but 1 comma max of array. This is the time complexity I'm taking. Okay. Now let's code it up, and I'll maybe once we get the answer, it will be clear how we are applying the binary search. Okay. Now let's write the main function. Let's call it. Let's write the main function. Okay. Let's keep it boolean because that is easier for us. So I'll keep it boolean is possible. Call it as possible. What would this take? This would take the array, and this would take the mid value. That is nothing but, let me call it mid only. No, let me not call it mid. Let me call it int balls and int max operation. Okay. Okay. Let me take int operations that it's taken is initially 0. Okay, let me iterate through the array for int num in array. Okay. Can I have something where int operation equals to math dot, I think C, right? Ceil of the number of balls that I have. So you're dividing num by balls minus 1. Makes sense. So you're dividing 9 or whatever it is. You're dividing 9 with 1, 9 with 2, 9 with 3. These are nothing but the number of balls. Okay, here, and then I'm gonna have to increment my count. Operations plus equals to operation. Okay. Here, can I add another condition? If number operation is greater than max operations, then I can just return false. Because if it's greater, why would I iterate through the entire array? Not required. Right. Perfect. Else I'm going to return. Right. Here is where I'm going to write my binary search logic. What would be my loop for int num in nums? Can I keep my you can of course keep less variables, but I'm just keeping this and then assigning it to high so that it's easily understandable. Max equals to math dot max of num comma max. Okay, so I'll keep int low equals to 1, int high equals to max, while low is less than or equal to high. Can I iterate through the entire thing where I say my int mid equals to low, let me write like this, low plus high minus low, right? This is the best practice of how you find it. Okay, now, Boolean result will be is possible of nums comma mid comma max operations. Okay. If result equals to false, again you can write this simply, but I'm just writing it so that it's easy to understand. False. If result equals to false, then so for example, for this we got false, for 1 we got false, so my low is over here, sorry, I mean your mid wouldn't be over here, but assume that for this I got false. Okay, this also I got false. Okay, wait, my bad. Let's assume that my mid is over here, this was my mid, and I got false over here. Now I can assume that if I got false for this entire thing will be false, right? So I'll have to shift my low. So I'll say that my low equals to mid plus 1. Else I'll store the answer where my int answer is 0. No, minimum value, right? I'll keep it as integer dot max value. Sorry. Okay. Else what I'll do is answer equals to math dot min of answer comma mid. Remember, mid is not the index, it's the element itself. Okay, now what I'm going to do is write equals to mid minus 1. I think this should suffice. Okay, do this, not right, low, sorry, high. So okay, perfect. Now what I'm going to do is return. Perfect. Okay, minus 1. So here that's what I considered, right? here and I'm going to the array to take two. I think I need to add another condition over here, because what if I get, like, four operations over here. Let me check it. Maybe I'll add another condition. If number of operations is greater than operations, I think this should work. Okay, let's run it. Let's see what we get. Okay. Maybe I need to convert this to a type. Perfect. I got accepted. Okay, on the first try itself, I'm very happy. Let's submit. Okay, we got a wrong answer, because 7 and 17, number of max operations is 2, output is 5, expected is 7. Okay, let's see why we got that. Maybe it's a simple mistake that we're doing. You have 7 and 17. Okay, max operation is 2. Now what is the minimum value? 1. What is the maximum value? 17. Okay, 17 plus 1 by, okay, maybe okay, yeah, I've just used this test case. Let's see. Okay, now let's go through this. 1 to 17, my mid would be 17 plus 1 by, let me keep it like this, low and mid, high and mid. 170, mid is 17 plus 1 by 2, 18, 9. 18 by 2 is 9. Okay, this is my mid for now. What am I going to do is I'm checking if 9 is possible to put. This would take 0 operations. For 17, it would take 17 by 9, that is let me write it actually. This would take 17, this would take for 19, for 9, this would take 0 operations. This one would take 17 by 9 is 1, 0 operations. Oh no, 2, because 17 sorry, this is 19, sorry, this is 9, makes sense. Okay, for seal of 17 by 2 will be 17 by 2 will be 1 point something, 17 by 9 will be 1.8. okay, that will be considered 2. 17 by 9, I'm considering the C value, which is 2, minus 1 I'm doing, so give me 1. Okay, 0, 1. Okay, now can I say that it's actually achievable? 17, break it. 9 and 8 I can break it. So number of operation record is 1. Correct. So now I know, hey, it is achievable by 9. I'll move my high equals to mid minus 1. High equals to mid minus 1. So my high was 17, mid is 9, low will be 1 itself, mid is 9, right? It will become 8. Now my mid will be 8 plus 1 by 2, 9. 9 by 2 is 4. 4, right? Am I moving I equals to mid minus 1? It's correct only. Okay, 4. Now for 4, with 4 I achieve 4. Okay, with 4 can I do it? This, okay, for 7 I have to break 7 into 2 ways, right? Okay, I have to break 7 into 2 ways. Oh, sorry, so, I'll just use a formula. 7 by 4 is 7 by 4 is somewhere around 1.75. If I take the seal value, that will be 2. So number of operation is 3. That is valid because you will split 4 and 3. Number of operation required is 1. Number of operation that is given to me is 2. Max operation is 2. Okay. Perfect. This is possible. What about 17? 17 by 4 is give me 4 4s are 16. So it will be 4 point something 5. So 4 operation. Because 4 4s are 16, CA value will be 5. 5 minus 1 is 4. So this will give me 4 operation. So it's not possible. So what will I do is I'll push my low as mid plus 1, 5, and high will still remain 8. Okay, high will still remain 8. Okay, what is my answer? Okay, wait, I need to update the answer as well. For 9 it is possible, with 4 it's not possible. So my answer for now will be 9. With 5 is it possible? Let's see. Let's take 8. Let's take this is for 4. Let's take it for 5. 7 by 5 is 1 point something. So flow seal value will be 2 minus 1 will be 1. So you split 7 as 5 and 2. This is valid. So I'll put. What about 17 by 5? 17 by 5 would give me 17 by 5 would give me 5 threes are 15. 5 3 point something. So give me 4 minus 1 will give me 3. So give me 3. So it'll be my 5. And total number of operation is 4. Okay. So it should not. So what will happen is event is wait one second. No. Sorry. I was considering my mid. Oh my bad. Sorry. I was considering my mid as 5. It's not 5 actually. I still haven't calculated my mid. 13 by 2 is 6. 6 is my mid. With 6 is it possible? 7 by 6 is 1. 2 minus 1 is 1. So you'll do it as 1. Okay, what about 17 by 6? 3 6 2s are 12. Let me do 17 by 6. 2.8. So it'll be 3 minus 1 is 2. We'll take 2 operations. So this is for 6, which will also not be possible. So I'll push my value to my mid to low plus 1. So 7 and high to be 8. Is it possible? While low is less than high. Okay. Why is it returning true? What if I remove this condition? Maybe this is what is causing the issue. Ouch. Sorry. Yeah, that is correct. 7 and 8. My mid would be 7 plus 15 by 2 is 7. I'll check with 7. 7 by 7 it's possible. So this will take me 0. 17 by 7. 2s are 14. 2 point something. So it will be 3 minus 1 is 2. 2 operations. Yes, it is possible. Value will get updated from 9 to 7, and this condition high will be high mid minus 1, low will be 7, 6. This is the breaking condition. So our logic is correct, perfect, just that we have something wrong in the code. We'll figure that out. Okay, maybe what we can do is possible nums net. Okay, high minus low by 2. Okay, logic is correct, but what is happening? Maybe here is where it's wrong. My binary search is correct. Okay, let me look at it. Yeah, so the thing is, my logic is correct. I did go through some iterations, but it was correct. Then, but I'm not sure what is wrong. So I had gone through the, how does seal work, right? What value does it produce? And it seems that the conversion is where the issue is, right? It was a lousy conversion because it was taking int, and the seal value probably was giving a whole number, and maybe because of that the issue was there. So that is why I use double, and I use double conversion, that it casted into double, and then whatever nums by balls, it cast into double, and it took that seal value, right? The reason was nums by balls will give you what? Will give you a whole number always, right? You are not taking seal of this, you're taking the int value of this, right? Now, so see, whatever it is, 17, whatever it is, 17 by 9, or it will give you 17 by 9 will give you what? It will give you a whole number. What is actually 17 by 9? 17 by 9 will give you see, now if you do 17 by 9 it will give you 1, but actual answer is supposed to be 1.888, and we're taking a seal of this, not seal of this, because seal of this would still be 1. This will be the seal value, but seal of this would be 2. That is the reason what I'm doing is I'm converting this to double, such that when I do 17 by 9 I get 1.88, and this math.c will convert it to 2, and then 2 minus 1, and then that I'll convert it to int. Now if I run this, I'll get the right value. Perfect. Let me submit it now. Hopefully I should get the right value. Perfect. Right, now yeah, this is the approach, and let's see what's the complexity. It should be, what did I tell you? The time complexity should be I wrote it over here, I'm not sure where I wrote it. Yeah, the time complexity should be O of log of 1 comma max of array. This is the time complexity for the binary search algorithm that we have written over here. But we are calling this possible function over here, right? This would take us n iterations because you're iterating through the array, right? Iterating through the entire array. This would take us n iterations. Now this would take us log of 1 comma max of array, right? So what would be your final time complexity? Won't it be when your final time complexity will be of n for the is possible function, and log of 1 comma max of array. This will be my final time complexity. Let's see. Perfect. 1 comma max of array is nothing but max value. That is it for today. I know this is a long video, but I hope you understood the complete solution. This is a very, very important concept where you're applying binary search on a range of numbers. Okay, so with this, if you understood this, you would be pretty much good enough to solve other binary range problems. So yeah, I would suggest you go through the problem again and then try solving it on your own. Stay consistent. Thank you.